Today we're going to take a look at fractional exponent exponential notation and radical notation. So as we look at our first example, 27 to the 2/3 power, we can pretty much see that this is an exponent and it is in a fractional form. Now there is an interrelationship between fractional exponential notation and radical notation. And it's sort of easy, but here's the recipe. So we want to convert this then to a radical. So we put our radical sign there. And what happens? Well, this becomes our, which is the base, becomes our radicand. Now the denominator of our fractional exponent, which is a 3, becomes the index number. And the numerator of our fractional exponent becomes the exponent to which we raise this expression. So that's the basic recipe of converting fractional exponential notation to radical notation. And then the opposite, if you have something like this, can be converted to that. Now, sometimes the exponent 2 is placed right under the radical sign as part of this radicand. But the preferred place is there. We now want to simplify this. And that's the use of this tool. Well, the third root of 27 is 3. And we now have 3 that will be raised to the second power. And we get an answer of 9. Now in MATLAB I saw this as one of the examples which is closely related to this. And you might say, well, what happens? Well, you take again, the base is indicated as this, that's enclosed within the parenthesis. Here we didn't need a parenthesis, but now we want to be sure the x and the 27 are included in the base. So that then becomes, again, radical sign. We use our index number as the denominator as the index number, and 27x. Again, the radical sign serves as a grouping symbol here, and this is all raised to the second power. Now, in simplifying this, that'll take us to our next step, where we can tease this apart, because this is a perfect cube here. So we could write it like this: the third root of 27, in a sense, times the third root of x, and then this is going to be squared, and this would be squared. So the third root now of 27 is 3 squared. And this becomes the third root of x squared. Now you would simplify this a little bit more. 3 to the second would be 9. So our final answer here would be 9, the third root of x squared. In this next example, we're seeing it in radical notation, and we want to convert it to fractional exponential notation. So again, the radical sign is a grouping symbol, so we would need to put what is under the radical sign, the radicand, in a parenthesis. to keep the integrity of that. And then now we're going to have a fractional exponent where the index number will be our denominator and the exponent to which this expression is raised becomes our numerator. And that is the answer. Again, the parentheses are needed. Otherwise, without the parentheses, it would only be the y that is raised to this power. And another example in which we have a fraction, and we're asked to write an equivalent expression with positive exponents, and if possible, simplify. Well, remember there is an exponent there of 1, and there is an exponent there of 1 in a sense for this. So in simplifying, the top stays the same, and we don't write the 1. And to convert this to a fractional exponential notation, our base is the radicand, which is x, and then in fractional form, our index number becomes the denominator, and the 1 goes up there. So that's meant to be, in fact, let me write that a little bigger here, x to the 1/5. And that is correct. Okay, just a simple, quick review of topic 4.2.